Hi, I'm Shifa from Evolve Robotics. I'm here to give a small introduction about PIC microcontroller. Before that, let's go through what is microprocessor and microcontroller. Can you tell me what is the need of this microcontroller and microprocessor? Yes, it is used to control and automate electronic system. So what is microprocessor? Microprocessor is an electronic chip that acts as a CPU and performs calculation and processing. It requires some external components for its proper functionality. The external components are RAM, ROM, input-output ports, timers, etc. Microprocessors are commonly used in PCs, laptops, mobile phones, etc. Example for microcontroller is Intel Pentium, Intel Core i3, i5, i7, AMD Ryzen, etc. The architecture of microprocessor is von Neumann architecture. Now, what is microcontroller? Microcontroller is an electronic chip that integrates CPU, RAM, ROM, input output ports, timers, and peripherals onto a single chip. So it is known as computer on a chip. It is programmed for a particular function and works only for that purpose. Can you spot out any area where microcontroller is used? Yes, home appliances such as washing machine, refrigerator, microwave oven, AC, etc. The architecture of microcontroller is Harvard architecture. Now let's move on to the difference between the microprocessor and microcontroller. Microprocessor requires external components for its full functionality and it is flexible and powerful for generating computing tasks. In the case of microcontroller, all the external components used for microprocessors are integrated on a single chip, so it is cost effective and efficient for dedicated application. The main difference between microprocessor and microcontroller come in their architecture. Microprocessor, as I have already told, the architecture is von Neumann architecture, which means the program and data shares the same memory. In the case of microcontroller, the architecture is Harvard architecture, which use separate program and data spaces or data memories. Now, with this, I'm concluding what is the difference between microprocessor and microcontroller. Now, I'm going to discuss about an example of microcontroller. There are different examples for microcontroller. They are Atmega 328, 8051 microcontroller, PIC microcontrollers. Here we are going to look in detail PIC microcontroller 16F877A. It is an 8-bit microcontroller developed by microchip technology. It is widely used in educational purposes and embedded system development. The full form of PIC is Peripheral Interface Controller. Now, we will check the advantage of Harvard architecture. We have already discussed that the microcontroller is having Harvard architecture. Harvard architecture means it is having separate memory spaces for program and data. The program memory is flash and the data memory is RAM. Another advantage of Harvard architecture is it is having independent buses for fetching instructions and accessing data simultaneously, which makes the execution faster. Here we are going to discuss about the key components of PIC16F877A architecture. The three main key components are high performance RISC CPU, pipeline instruction, integrated peripherals. What do you mean by high performance RISC instruction or high performance RISC CPU? The full form of RISC is Reduced Instruction Set Computer. There are two types of instruction set. Complex Instruction Set Computer, also known as CISC, and Reduced Instruction Set Computer, known as RISC. Once again, Complex Instruction Set Computer is known as CISC, and Reduced Instruction Set Computer is known as RISC. In this case, it uses Reduced Instruction Set Computer with approximately 35 instructions. And the second key component is pipeline instruction. What do you mean by pipeline instruction? Pipeline instruction means when one instruction is being executed, the second instruction will be decoded and the third one will be fetched. All these processes will be taking place simultaneously, which makes the instruction execution faster. And the last key component is integrated peripherals. PIC16F877A is having peripherals such as timers, ADCs, USART, I2C, SPI integrated in it. As we all know, there are two memories for program and data. The program memory is flash memory, which is of 8 kilobyte of size. It is electrically erasable and reprogrammable. And the data memory is RAM, which is of the size 368. It is organized into 4 banks for storing the data temporarily during program execution. And it also uses EEPROM to store the data permanently even when the power is not there. The size of EEPROM is 256 bytes. Now we are going to check what is input-output ports of PIC microcontroller 16F877A. Input-output ports means the pins that we can connect input devices and output devices. The total number of pins in 16F877A is 40. Out of these 40 pins, 33 pins are input-output pins. These 33 pins are converted into different ports. There are 5 ports. They are A, B, C, D and E. A is having 6 pins, RA0 to RA5. B, C, D have 8 pins each. They are RB0 to RB7, RC0 to RC7, RD0 to RD7. But E port is having only 3 pins, RE0 to RE2. This also have a special register known as trace register. Trace register is used to set the data direction, whether the pins are used as input or output. Using trace register, we will set a pin as input or output, or you can set the entire port as input or output. In our class, we have discussed about microcontroller, microprocessor, then difference between them, and then we moved on to the PIC microcontroller 16F877A. And in the next class, we will check how to set the configuration bits of 16F877A. So, thank you so much. Bye.